until you got that big back.
You comfortable? Yeah, I'm right. All right. Great, welcome everybody to the first sensiLab forum of 2017. So thanks all you all for coming. It's really great pleasure to introduce Ricardo, who's visiting at the moment, but he's going to be making lots of regular trips working at MARTA this year. And so I thought it'd be great for him to come and talk to us, because of course we're sensiLab moving down to MARTA by the middle of the year. We'll probably be working very closely with him, and so it'd be great to find out more about his research and what he does. And I think he's even got some exercises for us to do if there's time at the end. So please join me in welcoming, and thanks Ricardo for coming.
Thank you. Thank you very much. So yeah, thank you for the invitation and for coming. My name is Ricardo Sosa, and I was originally trained as an industrial designer, but since I was 11 I've been programming. So my whole life I've been with one foot in with computers and the other foot with creative design, and I believe that code and computer applications are part of my toolkit as a creative designer. And a few years ago, I met Andrew Vandenmoor in Sydney University, and this was 2004, and this is the first time I came across this idea of building physical artifacts out of data. And he used to run some really interesting activities with the students in the design computing degree in the Key Center for Design Computing in Sydney Uni, where I was completing my research, my PhD at the time. And I've been involved in a number of things, so I thought that since this is kind of my introduction to the community, I would do a little bit for a couple of minutes of data objects, which is the main topic for today, and just run very quickly through a lot of the things that I do, because it's always interesting to fit on a slide. I do a lot of agent-based social simulations to study things like social team and organizational creativity. That was basically what my PhD, the core of it was. Although I was involved in too many projects, I think that I'm always a bit promiscuous in terms of research, doing a little bit of a lot of things. This ended up in a patent application a patent was granted in Singapore, and now it's an application in the US PTO. And this came from a lot of coffee, a few weekly conversations with my computer vision colleagues. One of them, a professor, hired a postdoc that had done his PhD on CAPTCHAs. And we sat down and we thought, well, a lot of your problems in CAPTCHAs seem like a lot of my solutions in design, and vice versa. So why don't we talk about it? And we ended up designing a system that was presented in the Multimedia Systems Conference. This is my work on Southeast Asia, Philippines, and India mainly, and Singapore, bringing students to the field to work in participatory design projects. And we develop a framework from a lot of theoretical background from different fields to be able to understand how people come together to these participatory projects, and why they come together, and what happens when they come together, and if we could find any patterns in successful projects and not so successful projects, which is most of them. This one is an ongoing project with one of my PhD students. He's an industrial designer that was in my program in Mexico when I was teaching there in the undergrad program. And he's a very successful entrepreneur. He created 2 companies in Mexico, and when the time was to create his 3rd company, he thought, maybe I should take some time off and do a PhD. And he contacted me in Auckland, in New Zealand, where I'm at the moment. And he said, look, I want to do a PhD, but I don't want to become an academic. I just want to do a PhD to take 3 or 4 years of pressure and have really good ideas. And I thought, this is a fantastic challenge. So anyway, he's looking into rapid prototyping, additive manufacturing, rather, and how the use of additive manufacturing connects decisions made at the product level to decisions made at the firm level. So how the flexibility brought by additive manufacturing improves the design of a product, but also the design of the firm. So the value chain and the decision making and the people working in the project and so on. This was a study, again, a collaboration from a team teaching semester with a roboticist in Singapore, very successful person who has led a lot of teams in these international competitions, RoboCup and so on. And we started thinking about the spaces where Roomba and other service robots are going to be living in the next 10 years. And of course, we all know that there is a huge projected growth in service robots for residential and public spaces. But the spaces where they will be working, these robots, have not been designed for robots, or at least having robots in mind. So we thought, oh, maybe there are decisions made by roboticists, and maybe there are decisions made by product designers, and maybe they should talk to each other. And so we came up with the idea of robot-inclusive design, and we did some experimental tests to try different IKEA furniture to sort of say this IKEA furniture is Roomba-friendly and this one isn't Roomba-friendly. Lately, I started collaborating with expert in conversation analysis and we bought a Now robot. But the most interesting, and we did some HRI studies that we are still writing, and that's a bit painful. But then, almost by accident, I got into a different project in South Auckland, which is a very challenging ethnically and socioeconomic area in Auckland. And we thought that we could use robots not only for social interaction, but for social good, for social change. So we are bringing the robot to schools to talk to teenagers, and the robot, we found this, what I presume is a really interesting, we haven't published it, so all this is my assumptions, and from what we've seen on the ground, is that the robot is able to engage in very interesting conversations with teenagers that humans just can't. So the robot gets away with a lot of very interesting questions, and how, I think since we are very little, we talk to soft toys and they talk back, and there is a lot of that dialogue going on, and that's very much what is happening with Now. So we launched a campaign called Robot for Mayor 2030, and the robot is basically trying to learn how to be a good leader, and of course this is tongue-in-cheek. But and then working with the robot, we found out, again, related to the robot inclusive design idea, is that there is no such thing as robot ergonomics, and there should be. Mainly, designers should take into account robot dimensions and strengths and ranges of operation, such as their limbs and so on, to design, obviously for humans, but also for robots. And this is a very recent work that I'm doing with Lisa Grocott at the School of Design here in Mother. We started thinking about our research collaborations with other fields. And in doing that, we thought that maybe mapping a visualization exercise would be interesting to see how our collaborations happen or don't happen in different projects. And so I created a very simple, in a couple of hours, a very simple program with 4 variables, and then it asks you with how many outputs you got from that project, and in how many different fields, and all these things, and then you get a stochastic representation of your project. So then you can use it to either reflect on your practice, and you can also use it to talk to other colleagues and say, wow, I think our project is looking a bit like this or a bit like that. And of course there is no right or wrong, but it's mostly like a way of mapping visually with some parameters what you're doing. Now, that was very quick, but if you look at this, one thing that you might think, and I think a lot of review committees are thinking, is what is this person doing? What's going on? Is this a robot person? No, I'm not. Is this a captcha person? No, I'm not. Is this a participatory design person? No, I'm not. I'm a little bit of everything. And the way I'm slowly, after 12 years of getting my PhD, starting to realize is that the connecting line of all this is creativity, innovation, social change. That's what's driving a lot of what I do. So in essence, I'm not very committed to a technology or to a paradigm or a method, but I'm committed to pursuing and pushing the boundaries of what we know, what we mean when we say we are creative or other people are creative, or we are doing innovation, or we are doing social change. And I think as an academic, that's my long-term plan to contribute to the conversation of what's going on there. So that's where I'm coming to data objects. And here I removed the titles, but I left the images of where I've been to in terms of these institutions have paid me to do things. And so if you recognize more than one, we can always talk about these experiences after the talk or any other day that you want. All right, so back to the beginning, designing objects with data. What do I mean? This is going to be pretty short, I think maybe 15 minutes. And then what I did is I brought some materials that we use in this kind of exercises for you to give it a go, give it a try, and then maybe talk about it. Or if you feel that we don't need that and we can just have a nice Q&A, that's also fine. You will be basically driving the process. So you will let me know what you want to do. All right, so apologies if this has been, if you've seen this example 100 times, but for those who haven't, I thought it was really interesting. Quipu from the Andes. This is a very long tradition in South America and with the Incas, and even before the Incas. This is a necklace, and what each strand is doing, and there are knots on each of these, is they are portraying some data, basically, some information. So the fact that there are this many and this long, it's portraying some type of data. It could be about some accounting or crops or whatever needs to be displayed physically. And this is, as far as I know, one of the oldest examples of that physicalization. I think we all know about visualization. We've heard, we've seen some amazing work, but not that much in terms of physical representations. So the way I explain what I'm doing here is I'm taking data physicalization as this big left-hand blue world, and industrial design, which is, you have to remember, one of my first areas where I was trained as industrial designer. And these are just definitions that are debatable, but starting points. Data physicalization are physical artifacts whose geometry or material properties encode data. And industrial design is worried with defining a product's form, function, and meanings for some user, basically, in some context. And so in this intersection between these two worlds, I frame data objects as an area of opportunity that is not being tackled specifically as such, and not by many people anyway. So here we have things like people using Legos, or very sculptural, very artistic installations, or very sort of 2.5 dimensions representations, meaning pie charts or whatever, just with some extrusion, some three-dimensional volume, but it's basically a 2D representation. And of course, you can see in dataphys.org, you can see a huge list, a growing list. They keep it very current of all these projects. And then, of course, on the right, you have like the traditional, if there is such thing, industrial design or product design practice of crafting products. And so by data objects, what I mean is that the morphology, the configuration, the structure or the physical configuration, or the functions are data-driven. They are dictated by data. And so the artifacts defining attributes are derived from and connected to quantitative data. They are not, this is important, and the reason I make this distinction is because, of course, in design there is a long tradition of crafting objects inspired by data or inspired by issues, right? So that's kind of one of the standard approaches in design. But I'm not referring to only being inspired or raising a topic or an issue, but to actually linking it to numbers, to actual data, right? So I'm treating data as a design material and as a creative material. And what that means is that a lot of people, including me, have problems with this, right? And to me, especially since 2016 with Brexit and Trump and everything that is happening, to me, it's really important that we make this accessible to more and more people. And Hans Rosling just died last week, which was a shame, but we need more people doing interesting things with visualization and with, I suggest, with objects, with tangible objects, because still data visualization needs technology, needs power, needs a screen, needs internet connection often, and a certain level of literacy as well, visual literacy. Whereas interfacing or interacting with objects is a lot more, it goes back, further back into our sort of prehistorical sensibilities. And if you have, or if you're able to play with toddlers and young babies, we excel at manipulating space and materials and objects from a very young age. Before we can deal with 2D, we are in a 3D world. So what I'm doing here is and just going back to some projects, a project that I did almost 9 years ago, where I redefined what a table is. So a table, this is a table, and this is a table. And so here is the income distribution in New Zealand as of 2015, and the income distribution in Mexico as of 2015. And so just by the presence of these tables in front of you, you can see, and these are the, I think, the bottom decile, and then anyway, it's like the distribution of income of these two countries. And so there is no numbers being displayed, and even the colors and stuff becomes a little bit less relevant. But what is important is that the presence of these objects communicate issues. And again, I go back to all that happened in 2016 and the role that data objects can have in, let's call it, design activism, bringing issues and framing issues for everyone to have a common ground. I think a lot of what happened, a lot of the explanations of what happened in the US elections is that people see the present reality very different. People explain the reality very different. So these things, by being in our world and being there, I think one of the intentions is that people then sort of have to agree that things are with a certain shape, and that the problems have a physical representation that talk about stability and instability, or even like crazy proportions because of what they are reflecting. So what I've done, and this is a paper we are in the final draft, and you know what that means, is with a team of my colleagues putting together like principles of design, but how they apply to the design of data objects. So these are all principles that industrial designers know very well, but that they are not necessarily being applied or explicitly applied in the design of data objects so far. So it's a long list. I won't go through all of it, of course, but I will just choose one of them on each table. There are 5 tables. I can just choose one of them, pretty random, and just show you one of the exercises that, in this case, our students from last year, this is the first year of a degree called Creative Technologies in Auckland, and we gave them this material, and within a week, they produced, with a shared data set, they produced this representation. So the data set was something called the Time Use Survey. I don't know if you're familiar with that, but it's now done in many countries. And it's basically a very interesting survey that it's done as a survey, but it also includes like journaling. So it also asks people to register over, I think, a week or more, their daily activities. And then these statistics show how people are spending their time, basically, either between like sharing their time with other people, with strangers, or with family and friends, what they are doing in that time, if they are watching TV, or if they are studying, or working or sleeping. So it's a very interesting snapshot of where societies are, basically, on how they are spending their time, basically, or spending their lives, right? So we gave this to this group of 18-year-olds, 80 students. And in this case, for instance, I can connect this principle to define data-driven perceived affordances. So physical properties that help users perceive the function of an object and the actions to operate or interact with it. And this is a case of a book that what the student did is, in proportion to the number of pages in the book, he glued like advertising material to the pages to represent how the change in 10 years, I think, in the 2 instances in New Zealand where the time use survey has been done, of how much people are not reading and buying, or spending their time shopping or watching TV instead. So that one is going down and the other one is going up. But this is a very intuitive way of demonstrating that, if you want, that tension between spending your time reading versus spending your time shopping or watching TV. These are the principles of semantics, and I just choose one here. Define literal and abstract elements by identifying iconic, indexical, and symbolic signifiers. This is a shirt, a blouse by a student. And to be honest, I don't remember. I have to go back and read the paper to remember what was embroidery about, but there were 2 sets, and I remember she was prototyping one version where the buttons changed size, but in the end she preferred this manual embroidery on the fabric. Principles of social cognition. So this is just to put it as a principle, but really it's more like a family of principles dealing with organization, how the parts of an artifact or a product are organized. And there are a lot of sub-principles like framing, mapping, chunking, hierarchy, layering, priming, and so on, in order to process, manage, remember, and reinforce information, or to activate specific concepts and memories. And this student chose a table with sort of DIY activities that people do, how they spend their time doing DIY activities. And then the idea was to have several hammers, and then the handle of the hammer would be, again, the decreasing time that people in New Zealand are putting into manual work at home, like for hobbies, right? And so it got to a point, of course, where the handle was too thin for the head of so the head of the hammer was constant, and then just the handle would change, and sometimes you were like, this is going to break. And his statement was, well, something is breaking, and how we are repairing things, fixing things, or creating things at home. Principles of usability. This was, from my point of view, my favorite data object, and this person took the concept of playfulness. So how do you motivate people, or give rewards, or create flow, or feed this hunger for information and curiosity? And what this is, again, I don't know the details. I would have to go back and read. There is a blog post from each of the entries, so the students were asked to post in their blogs an explanation of how they created it and how it works. So I can direct you to it if you're interested. But this is basically a board game that you play with 2 people. And so you move things depending on how you think the world should be in terms of what people, I think this had to do with how females and males use their time. And so it had to do with gender imbalances and hierarchies and power. And I think the game was to move this, to form these towers and to move them around. And there was like realizing how people actually use them versus how they should be using them. So projecting the expectations and even the ethics of how it's perceived. And the last one, again, is just to put it in a place, but principles of functions. So we're saying that function follows data, and this was, again, one of very interesting. These are first semester projects, and this student was able to hack a keyboard and basically modify. So you can see some keys have like a little bit of, I think, nail polish on them. And what they are showing, that was just to show us as the lecturers which were the keys that were not working. And actually they were working, but they were mixing the signal. So it was actually portraying something on the screen. I think she used processing actually to do that. But anyway, it was a very nice implementation in a week of a very abstract concept of how what you typed, I can't remember the number, where was a link to the number, I'm sorry, but the project was, the working prototype was really interesting, that she could do it with 0 skills in coding, and well, that semester is when they learned programming, so that was her first introduction to processing. All right, so what I did here is, this is some data from the Australian Bureau of Statistics. These are the income for the whole population, income distribution from 2003 and 4 to 2011 and 12. And these are the lowest quintile, so dividing the population in 5 groups, and then from the lowest to the highest and the average for each group. So you can see that the lowest income has increased from 30,439 to 31,205, whereas the richest have gone from, on average, 1.7 million to 2.2 million. And so what I thought we could do, if you're interested, is we could map and have a go at creating an artifact out of these numbers. I realize it's after lunch, so I don't know how used you are to sort of hands-on quick exercises that we could do in 10, 15 minutes. Or if you would rather talk about this, we could have a Q&A and talk about it instead of doing it. Whatever you prefer to do, really.
Nice.
Let's mess around.
Yes, excellent. Cool. So what I'll do is I can put these materials there, and you can feel free to come and grab them. We have, I'll just explain, we have these wooden sticks with colors, and we have these little ones as well that you can use. We have some plastic bits, very colorful, and we have some card that you can also use to fold and do some surface materials with some scissors and some glue. All right?
Are we all working individually or?
Yeah, well, as you want. There are no rules.
I'm not that group. I'm working with.
Yes.